Welcome to the Innovators, the podcast where we talk to the people building the future. In each episode, we sit down with technologists, founders, researchers, and engineers who are doing real, impactful work. They're applying technologies in ways that change how we live, work, and think. Whether it's breakthroughs in AI, climate tech, health systems, or digital infrastructure, this show is about the people turning ambitious ideas into working systems. No hype, just thoughtful conversations with the folks making it happen. Innovators, a podcast about amazing people who are doing amazing things. I'm John Biggs. Today on the show, we have Francis Roy. He's CSO, Chief Strategy Officer of Quaise Technologies. Francis, welcome.
Thank you, John. It's a pleasure to be with you today.
So I wrote this up just recently. What sounded coolest about this whole project is that this whole product is that it becomes sort of a general multi-purpose charging system for almost anything, including drones, including UAV, including land vehicles, all that sort of thing. Something that can be, deployed in the field and things can come and charge on it. But why don't you tell me a little bit about what you guys are building?
I think that's a good way to put it. What we're building is the electronic architecture that will allow unmanned system to access energy anywhere without human intervention. So that's what we're focused on. Quaise, John, we like to think that unmanned systems, kind of like cars, need one way of accessing the energy, whether they're operating in Alaska, in Jamaica, or in the UK, right? And whether those unmanned systems have 2 wheels, 4 wheels, if they swim, if they fly, it doesn't matter. They need one way to access energy. And like all our vehicles have one way of accessing energy, they're going to the fuel pump.
So when I first saw this, I think the description was sort of like a mat that a device can like land on or roll up to and just get charged. Kind of like I remember there was a drone technology that was supposed to allow to recharge the drones from power lines, that sort of thing, or some sort of like thing that's strung up. But it seems like this is a little bit more generalized, that almost anything can use this system?
Absolutely. So the math is one iteration of our technology, John. What we're focusing on is turning large surfaces into energy access point. Now, in the case of the math, it's a very soft-oriented operator solution because it's light, it's portable, it's foldable. You can drop it anywhere. You can connect any source of energy to it, and then it's meant to recharge drones on the ground. Like I said, it's one iteration of our technology. What we're focusing on is our ability to have a big surface and turn it into an energy access point. And the reason why we're focusing on that is because if it's a big surface, it doesn't matter what the form factor of the robot is. You're on the surface, you access energy, and it's perfect to be the agnostic charge anywhere solution that military is looking for. But the one, Matt, you've seen is the first iteration and one of our first solution that we take to market.
And you actually had a piece of hardware that you can show us?
I can. So the guts of the mat is actually this electronic here that we call the Q6. And in essence, this is Quaise's brain power, if you want, Quaise's core technology. But the beauty of the Q6 is we encapsulated all of our electronic architecture into one piece of hardware that can be used in any use case. So if you want to recharge on the water unmanned vehicles, this piece of technology is going to be able to do that. If you want to turn a military vehicle into a mothership for robots and you need a way to recharge those systems, then the Q6 is going to be able to deliver that. It's kind of like a chip when you look at a computer. This is the chip, and then the solution is the computer or the vehicle.
So the expectation is that the drones go out, they do whatever they're supposed to do, the mission, and they can come back, recharge, and then all autonomously, right? So they land, start to charge and go, or they swim up, start to charge and go.
Exactly. And I have the technology here that I can actually turn on, and you'll be able to witness what makes our technology unique and why it delivers on that promise. As I said earlier, if you have a big surface, it takes away the need to have a precise alignment between the transmitter and the receiver, which is just not viable in a battlefield context, right? So in this case, I have a large surface. If we think that this is a robot, if the robot is on the surface, the robot can access power. So because it's a surface, it can be anywhere. It's got a level of resiliency that's unique to us as well. It pushes power through the breeze, so it offers the operator a level of trust that the system is going to be able to access power that is unmatched in the business. And in a nutshell, really, that's what it is. Because it works through the breeze and it's got no alignment and it's a flat surface, then it's very easy to adapt to any context.
And what's the charging time?
So today, the technology, the Q6 can push up to between 100 and 250 watts. So this is how much power we push. Depending on what battery we're charging, then the charge time is going to be affected. So if we push 100 watts to a battery that's 100 watt hour, then it's going to take you an hour to recharge that battery. In essence, right?
Interesting.
And it's hard to always call what the charging time is going to be because we're agnostic, and it depends really on what robot is coming in and drinking from the fire hose or drinking from the energy access point. Our job is to make the energy available.
And what needs to be done to the drones to allow them to use the Q6?
So I have an example here with me. We built our electronics, our receiving electronics, into a small little bracket. This is the physical interface that we use for a Parrot Anafi drone. So all we have to do now is to fit this bracket between the body of the drone and the battery, and then your drone is now compatible. This piece of technology here that we're looking at is weighing only 40 grams. So it doesn't have a major impact on the drone's autonomy and flight ability and superpowers, but you're giving it a way to recharge without human intervention.
How popular is the technology now? Are you being able to sell into any military organizations?
Yep. So the mat that we refer to as the Fox, which is our product, which is also distributed by Galvian, and they refer to it as the UX, is has already been purchased for testing by some military organizations within the NATO environment. We're really happy with that because it's really the beachhead product that we're taking to market with our technology. That transaction has been executed, and we're really happy with the feedback that we're getting.
Why hasn't this technology been implemented so far?
I think it's new. Also, the military, as well as the OEMs and the prime contractors, have to grasp it at first, and they have to look at it and figure out where is it going to be integrated, what ConOps it's going to serve. And for your audience that are very familiar with the military environment, like the ConOps are driving everything, right? So when you come up with something that is good, then it's a several phase process where we're going to get, all right, is it really delivering on the promise? Yes, it does. Now, what ConOps are we going to apply the technology to? And this is kind of where we're at in the adoption life cycle, if you want.
How much does it add in cost to a standard drone?
The receiver is by far the cheapest or the less expensive part of our components. So we're talking hundreds of dollars, something very, very minimal at that end. The most expensive component of our architecture really is the Q6 transmitter that obviously is where all of the magic is happening and where the smartness resides. But our way to market is to keep the receiving piece that's going on the robot as cheap as possible. And also we want to make it as easy as possible for OEMs to integrate or to make a physical interface for retrofitting.
I mean, yeah, for me, I love this image of like the drones just coming back like hummingbirds almost and landing on this thing and sipping their energy and then they go back out again. It's a fascinating solution to a pretty thorny problem.
Well, as we learn from spending quite a bit of time with the military, you'll often hear that the experts are doing logistics and the amateurs are doing strategy. And the reason being that if you can't take food, fuel, water, and ammo to the front line, then you won't be executing any strategy, right? So now that we're swapping humans for robots, then we have a new logistical challenge. And that's how do we take power from safety to the front line, and on the front line, how we give it to the robots that are operating in there instead of being humans, right? So this is kind of what we're focusing on. And the fact that you can have a surface and your hummingbird comes and lands on it because it's a surface. We don't care who made the hummingbird and how big the hummingbird is. It doesn't matter. We just give power to any one of those hummingbirds or walking robots or rolling robots, really.
What's next for the company?
So what's next for us is to move into the adoption phase. We're working really closely with robot OEMs and prime contractors to integrate into their solution buildings. So the prime contractors have the requirements. They're working on the projects. They're building the solutions. They know where we fit and how we add value. And we work with them to provide them with the electronics so that they can take innovative solutions to the market and take autonomous systems and autonomous operations to the next level. We're really focused on that. Our business model is not to build solutions, but it's to provide the electronics that delivers power that can be integrated into OEM solutions, but we want to keep it as fast and as easy as possible for OEMs to work with us. One of the things that we're really, really proud of is we've integrated 9 solutions in the last 2 years. So that speaks volume about our ability for them to take our technology, put it in their systems and deploy it and test it and prototype it and get it to work, right? So we want to continue to focus on building our relationships with the prime contractors and the OEMs and move to the industrialization phase of our life cycle as a startup. So that's what's next for our company.
So we'll send folks over to quazetech.com, Quaze tech.com. Thank you for joining us, Francis. It's been fascinating.
It's been a pleasure. Thank you very much, John. Have a good day.